Hey everyone, let's start at the very beginning and really understand what the Model Context Protocol is all about. Now, I want you to imagine for a moment that you're trying to charge your phone, your laptop, your tablet, and your smartwatch. In the old days, you'd need four different chargers, four different cables, and four different power adapters. It was a mess, right? Well, that's exactly what the AI world looked like before MCP came along. Every time you wanted to connect an AI system to a data source, whether that's a database, an API, or a service like Microsoft 365, you needed custom code, custom authentication, and custom error handling. It was like having a different charger for every device. MCP, introduced by Anthropic in November 2024, is essentially the USB-C of the AI world. It's one universal standard that allows any AI application to connect with any data source in a secure, standardized way. But here's what makes this really revolutionary. It's not just about convenience. Before MCP, AI systems were essentially living in isolation. They could process text, they could generate responses, but they couldn't access live real world data from your business systems. Imagine having a brilliant assistant who's incredibly smart, but can't look up your calendar, can't check your email, and can't access your company's databases. That's where we were before MCP.
Now, let me walk you through the specific problems that MCP solves.
Because understanding these problems is crucial to appreciating why MCP is such a game changer. First, we had the data silo problem. Think about this for a second. You've got your AI model that's incredibly capable, but it's completely cut off from your live business data. It's like having a world class chef who's not allowed to see what ingredients are in your kitchen. The AI might be brilliant at analyzing data, but if it can't access current information from your CRM, your databases, or your business systems, its usefulness is severely limited. Second, we had massive security concerns. The traditional approach was to give AI systems direct access to databases or APIs. But think about what that means. You're essentially handing over the keys to your entire data kingdom to an AI system. That's terrifying from a security perspective. You're creating multiple attack vectors, credentials are scattered across different systems, and you have no centralized way to manage access or monitor what's happening. Third, integration complexity was killing productivity. Every single data source required its own custom integration. Want to connect to Salesforce? Write custom code. Need to access Microsoft 365? Write different custom code. Want to add PostgreSQL access? Yet another custom integration. Each one had different authentication methods, different error handling, different data formats. It was like having to learn a completely different language for every system you wanted to talk to. Fourth, maintenance overhead was becoming unmanageable. Imagine you have 10 different AI integrations, each with its own custom code. Now, one of your APIs changes their authentication method. You don't just update one place, you have to hunt down every integration that uses that API and update them individually. Multiply that by dozens of integrations and constant API changes, and you've got a maintenance nightmare. Fina, lie inconsistent made everything harder. Uh, every service had its own way of doing things, different parameter names, different response formats, different error codes. It was like trying to have a conversation where every person speaks a different dialect of the same language. MCP solves all of these problems with one elegant solution, a standardized protocol that works everywhere, handles security centrally, and provides consistent interfaces regardless of what you're connecting to. Now, here's where we need to really understand the architecture of MCP because this is foundational to everything we're going to build. MCP consists of four core components, and I want you to think of this like a well orchestrated team where each member has a specific role and they all work together seamlessly. Let me paint you a picture of how this works in the real world. The first component is the MCP host, and this is like the conductor of an orchestra. The host is your AI application. It could be Claude Desktop, it could be VS Code, it could be the Streamlit interface we're going to build in this course. The host's job is to coordinate everything. It manages the user interface, it understands what the user wants, and it orchestrates all the other components to make things happen. Think of it as the brain of the operation. The second component is the MCP client, and this is where it gets interesting. The client lives inside the host. It's like having a specialized communication officer embedded within your main application. The client's job is to handle all the protocol level communication with MCP servers. It knows how to speak the MCP language, it handles connection management, and it translates between what the host wants and what the servers understand. Here's a crucial point: there's a one to one relationship between clients and servers. Each client connects to exactly one server, which keeps things clean and manageable. The third component is the MCP server, and this is where the real capabilities live. The server is what exposes tools, resources, and prompts to the AI system. It handles authentication with the actual data sources. It implements the business logic for different operations, and it provides a standardized MCP interface regardless of what's happening behind the scenes. In our project, we're building an MCP M365 SERVER that knows how to talk to Microsoft Graph APIs, handle OAuth authentication, and expose Microsoft 365 capabilities through MCP protocol. The fourth component is the data source, and this is the actual system that contains your data. Microsoft 365, GitHub, PostgreSQL, Salesforce, whatever you're trying to connect to. The data source doesn't know anything about MCP, it just provides its normal APIs and services. Now, here's the beautiful part about this architecture: the flow is clean and logical. The host creates clients based on what it needs to do. Those clients connect to the appropriate servers. The servers access the actual data sources using whatever authentication protocols those sources require. And then the data flows back through the same chain, from data source to server to client to host to user. In our Microsoft 365 project, this looks like our Streamlit UI with Agentic AI acts as the host. It has a built-in client that connects to our MCPM 365 server, and that server accesses the Microsoft Graph API. It's like your ID uses a connection manager that talks to an API gateway that fetches from Microsoft 365. Clean, secure, and maintainable.
Now we're getting to the heart of what makes MCP so powerful.
The three fundamental primitives that define how AI systems interact with external capabilities. I want you to think of these primitives as the vocabulary that AI uses to communicate with the outside world. Just like human language has nouns, verbs, and adjectives that combine to express complex ideas, MCP has tools, resources, and prompts that combine to create sophisticated AI powered workflows. Understanding these three primitives is absolutely crucial because they read the building blocks of every MCP system you'll ever encounter. Every interaction, every capability, every feature you can imagine will use some combination of these three primitives. So let's dive deep into each one and really understand not just what they are, but how they work together to create magic. Let's start with MCP tools, and I want you to really understand what makes these special. Tools are executable functions that AI models can automatically discover and invoke. But the key insight here is that they're model controlled. What does that mean exactly? It means the AI itself decides when to use these tools, how to use them, and what parameters to pass to them. This is fundamentally different from traditional programming where you, as the developer, explicitly call functions. Here, you're giving the AI a toolkit. and the AI figures out which tools to use based on what the user is asking for. Think about this for a moment. It's like having a really smart assistant who not only knows how to use all the tools in your workshop, but can also figure out which tools are needed for any project you describe. You don't have to tell them use the hammer, then the screwdriver, then the drill. You just say, I want to hang a picture, and they figure out the sequence of tools needed. Let me give you a concrete example that will make this crystal clear. Imagine you're working in an ID and you ask, what's the weather like in San Francisco today? In a traditional system, you'd need to write code that explicitly calls a weather API. But with MCP tools, here's what happens. The AI recognizes that you're asking for weather information. It automatically discovers that there's a get weather tool available. It figures out that it needs to call this tool with a city parameter. It invokes get weather with the parameter San Francisco. The tool returns structured data like temperature, humidity, and conditions. The AI then synthesizes this data into a natural language response. It's 72 degrees and sunny in San Francisco today. The beautiful thing is that you never had to know the tool existed. You never had to learn its parameters, and you never had to format the API call. The AI handled all of that automatically. In our Microsoft 365 project, this becomes incredibly powerful. When someone asks, show me any team service issues from this week, the AI will discover our get that service messages tool, figure out that it needs to filter for teams and set a date range for this week, make the appropriate tool call, and present the results in a user-friendly way. Our Excel export functionality is also implemented as an MCP tool, which means the AI can automatically decide to generate Excel reports when that would be helpful to the user. Now let's talk about MCP resources. And this is where the concept gets really interesting because resources work differently from tools. While tools are about taking actions, resources are about providing context and information. Think of resources as being like reference books in a library. They're there for the AI to consult when it needs background information, but reading them doesn't change anything in the world. The key characteristic of resources is that they're application controlled, which means a server decides what information to expose and how to organize it. Resources are read only by design, they provide data without any side effects. Is similar to GET endpoints in REST APIs, but with much richer context and metadata. Let me give you an example that illustrates the difference between tools and resources. Imagine you're working on a software project. A tool might be create bot pull a request. That's an action that creates something new in your repository. A resource might be file main.p that's providing access to read the contents of a specific file for context. The AI can reference the file contents to understand your code base, but accessing the resource doesn't modify anything. In our Microsoft 365 project, we might expose service announcements as a resource. The AI can access current Microsoft 365 service announcements to provide context when answering questions about service status, but accessing this resource doesn't change any service states or configurations. Our Microsoft 365 Graph Service provides resource-like access to various Microsoft Graph data, user information, group membership, service status that the AI can reference as background context when formulating responses. Here's why this application control approach is so powerful. The server can manage access permissions, data freshness, and formatting consistently. The AI gets rich, structured context without having to understand the complexity of different data sources or authentication mechanisms,
Now let's explore MCP prompts.
which solve a completely different but equally important problem. Prompts are predefined templates that help users interact optimally with the available tools and resources. Think of prompts as being like recipes in a cookbook. They provide step by step instructions for accomplishing complex tasks using the available ingredients, which in this case are the tools and resources. The key insight about prompts is that they're user controlled. Unlike tools which the AI invokes automatically or resources, which the server manages, prompts are explicitly selected and invoked by users. They represent best practices and proven workflows that have been codified for reuse. Here's why this is so valuable. Imagine you're new to a complex system with dozens of available tools. Without guidance, you might not know the optimal way to accomplish common tasks. You might use the wrong sequence of tools, miss important steps, or not take advantage of all available capabilities. Prompts solve this by encoding expert knowledge into reusable templates. Let me give you a concrete example. You might have a code review assistant prompt that guides users through a comprehensive code review process. The prompt template might say, review this code for security issues, performance problems, and adherence to best practices. Use the static analysis tool, check for vulnerabilities, the performance analyzer tool to identify bottlenecks, and the style checker tool to verify coding standards. Provide specific recommendations with line numbers and suggested fixes. When a user selects this prompt, they get a proven workflow that uses multiple tools in the optimal sequence. In our Microsoft 365 project, we could create a service health report prompt that guides users through generating comprehensive service health reports. The template might instruct the AI to check current service status for all Microsoft 365 services, review recent incidents and their impact, analyze trends over the past week, export findings to Excel with timestamps and charts, and format everything into an executive summary. This transforms what could be a complex, multi step process requiring expert knowledge into a simple, one click operation that anyone can use effectively. All right, everyone, now we're getting to the part where everything clicks together. This is where we stop talking about individual components and start seeing how they actually work together in real world scenarios. Understanding the relationship between MCP hosts and tools is absolutely crucial for building effective systems. And I'm going to walk you through this step by step because this is where many people get confused about who does what and when. Think of this like learning how a car works. You can understand what an engine does, what wheels do, and what a steering wheel does, but the real magic happens when you see how they all coordinate to get you from point A to point B. That's what we're exploring now with MCP components. Let me break down the fundamental differences between MCP hosts and tools, because getting this distinction right is the foundation for everything else we'll build. The MCP host is like the conductor of an orchestra. It's the AI application that coordinates the entire system. Host manages clients, handles overall orchestration, acts as the system coordinator, and provides the user interface. It's the brain that understands what the user wants and figures out how to make it happen. MCP tools, on the other hand, are like specialized musicians in that orchestra. That executable functions exposed by servers that perform specific actions. Tools are model controlled, meaning the AI decides when to use them and they act as action performers and capability providers. Here's the crucial relationship. The host contains clients that discover tools, while tools are exposed by servers and invoked by hosts. It's like having a project manager who maintains a directory of specialists and calls upon them as needed. The host doesn't perform the actual work, it coordinates and delegates to the appropriate tools based on what needs to be accomplished. Let me show you how this works in practice with a simple weather query example that everyone can understand. Imagine you're working in your ID and you ask, what's the weather in San Francisco? Here's the complete flow that happens behind the scenes. First, the ID, acting as the MCP host, receives your natural language request. The host then discovers available tools by having its MCP client query connected servers for tool definitions. The weather MCP server responds saying, I have a get weather tool that accepts a city parameter. Next, the ID's AI model recognizes that you need weather data and decides to invoke the get weather tool. The client sends the tool called get weather with the parameter city equals San Francisco to the weather MCP server. The weather MCP server then processes this tool call, authenticates with the actual weather API, fetches the current data like temperature 72 degrees Fahrenheit and condition sunny, and returns this structured response back through the chain. Finally, the ID host receives the tool response, the AI synthesizes it into natural language, and you see it's 72 degrees and sunny in San Francisco. The flow summary is beautiful in its simplicity. Host coordinates, client connects, server exposes, tool executes, and data source provides. Each component has a clear role, and they work together seamlessly. Now let's see how this same pattern works in our Microsoft 365 project, but with greater complexity and real business value. When a user asks our system for a team service health report, here's the detailed flow through our Azure Functions architecture. The user queries our Streamlit UI, which acts as the MCP host. Our Agentic AI component, running as an Azure function on port 7071, processes the natural language request. The MCP Microsoft 365 host class analyzes the query intent, determines confidence levels, establishes a routing strategy, and discovers available Microsoft 365 tools. Next, the host invokes our MCP Microsoft 365 server, also running as an Azure function on port 7071 via its MCP client. The client calls get that service messages with the query parameter for team service health. The server authenticates with Microsoft Graph using Auth2, applies service filters and pagination rules, and fetches data from the Microsoft Graph data source. The Graph API returns team service status data, which the server formats into standardized MCP format and sends back, including a messages array and a total account of 15. Back in the Agentic AI function, the host processes this server response, formats the data for user presentation, and displays found 15 team service messages, two critical issues. But here's where it gets really interesting. If the user requests an Excel export, our Excel export tool, another Azure function on port 7071, is automatically invoked. This tool generates an Excel file with multiple sheets and provides it as a downloadable file for the user. In our implementation, Agentic AI serves as the MCP host. MCP Microsoft 365 Server serves as the MCP server. Excel export serves as the MCP tool. Streamlit UI runs as the web interface on port 8501. All these components work seamlessly together using Azure Functions serverless architecture, giving us both scalability and cost efficiency. Now, let me show you why this MCP architecture is so revolutionary compared to how we used to build these systems, because understanding these benefits will help you appreciate why it's worth learning this new approach. In traditional integration approaches, you had to write custom code for each API you wanted to connect to. Every single integration was a snowflake, completely unique and requiring specialized knowledge. With MCP, you have one standardized protocol that works for all services. It's like the difference between needing a different key for every door in a building versus having one master key that opens everything. Discovery in traditional systems relied on hard coded function calls. You, as the developer, had to know exactly what functions existed, memorize their parameters, and explicitly call them in your code. With MCP, you get dynamic tool discovery and invocation. The AI can ask servers what they can do and automatically figure out how to use available capabilities. Maintenance was a nightmare in traditional approaches because you had to update each integration separately when APIs changed. If you had 10 applications using the same service and that service updated its authentication, you had 10 separate updates to make. With MCP, you update the server once and all clients immediately benefit from the improvement. Security in traditional systems meant credentials scattered everywhere in configuration files, environment variables, and hard coded in applications. It was nearly impossible to audit who had access to what. MCP centralizes authentication in the servers, giving you single points of control for security policies and access management. Finally, extensibility required code changes in traditional approaches. Want a new feature? You're modifying application code. running tests, and deploying updates. With MCP, extensibility often requires just JSON configuration additions. Need a new tool? Update a server configuration. Want to expose new data? Add entries to the resource catalog. The result is that MCP truly provides the USB-C equivalent for AI systems, universal connectivity with dramatically better security, maintainability, and user experience. There's not just an incremental improvement, it's a fundamental paradigm shift that makes AI powered applications actually practical for enterprise use. So, guys, that wraps up our MCP theory session. You've now got a solid understanding of the fundamentals and how MCP ties everything together. In the next session, we'll move one step further and dive into the architecture details of our MCP project, breaking down each component, its role, and how everything connects in practice. See you there.